The domain and range, just like we did on Friday. Anybody want to try this one? For 10 Magic Money tickets. Remember Magic Money, you can use it to buy chips now, a couple of noodles, pens, pencils, kind of cool. That's true, that's coming up too. Anybody? Hit it, Ayala. Pick any color. No, it's okay. So Ayala's going to come and try it. Go for it. Pick any color. Let's watch those wires. Sure. Which one's wrong, Valero? The range? What should the range be? All real numbers? Okay. Let me put that on hold. Let me do the domain real quick. So the domain, remember last week, the domain we defined as any values that x can be. So if you want to look for the domain, scan your pencil or pen, whatever you're holding in your hand. Go from left to right along the x-axis. So here we go. I'll use green. So here's your x-axis. The question you're asking yourself is what values can x be? I'm going to go from left to right. From left to right. So from left, can x be any value out here? Yeah, because look at this is an arrow. This graph extends this way. So whatever x is over here, like say x is negative 10, y will be some value up here. X is negative 11, y will be some value up here. So x is defined for negative infinity. It'll go all the way to negative infinity. So for sure negative infinity, any x values this way, and positive infinity. If x is positive 20, let's say, y will be down here. If x is positive 30, y will be down here, and so on, because you have the arrow. So this is right. Domain is all real numbers. Make sure you have that on your number 3. Now, little FYI, if you get sick and tired of writing all real numbers, there's an abbreviation, a symbol in mathematics that stands for all real numbers, and this symbol, I'm going to write it down. It's a double bar that looks like an R. So from now on, you can write this for all real numbers. It's a double bar that starts with a little R there. Instead of writing all real numbers out, just write this, just so you know. Okay. Double bar with an R, just like that. All right, now range. What values can y be? Valero is arguing that, well, this is saying y can only be greater than or equal to negative 1. So let's see. Negative 1's right here, so y can only be these values up here. Because all these values of y are greater than negative 1. So can y be negative 3? It's right here. Yeah, look at it right here. Right, so y can be negative 5 down here. It's going to be all real numbers. So y can be any values, negative infinity, 0, positive infinity, there's going to be some y. For negative 2, y would be right here, or actually positive 2. Positive 3, y is right here, so on. I'll give you 2. So the range should also be all real numbers. Check it out. Cool. Let's go to example 4, unless there's any questions. Let's find the domain and range of this puppy. Okay. It's a function, totally, because it passes the vertical line test. If I draw a bunch of vertical lines, it only cross once. All right, so for my domain, let's see here. From left to right, I'm going to use green. From left to right. If x is, say, negative 10, is there a y value for negative 10? It is. Look at this. Goes all the way down here, the arrow. So if x is negative 10, y will be down here. If x is negative 8, let's say, y is right here. Right? Negative 6, y is right here. Negative 5, y is right here, and so on. So x is defined to negative infinity. Coming right here, x is defined here. If x is 0, y is this. If x is 1, y is here. If x is 2, y is here. How about over here? If x is 10, yep, y is defined down here. These arrows indicate going that way. If x is 11, y is down here. So it looks like the domain is all real numbers. I'm going to put that for number 4. So remember, domain, you're scanning your pencil from left to right. Now let's do the range. I'll do the range in blue. So for the range, I'm going from bottom to top on the y-axis. What values can y be now? Let's just start with some negatives just for testing. Can y be negative 1, negative 2, negative 3, negative... Can y be negative 4? Yes, right here and here. Look at. Can y be negative 3? Yeah, right here and here. Y can be negative 2 here and here. Y can be negative 1 here and here. Y can be 0. Y can be 1. Y can be 2. Y can be 3. Y can be 4. Look at there. But stops. Y can be anything greater than 4. If y is 5, there's no values for the function at this high. So it only goes from 4 and below. So my range is y can be less than or equal to positive 4. Any numbers on the real number line that's less than or equal to 4, that's your range. Good, Valero. 2 more examples. We're just going to go up to number 6 today. All right. 5. Is that a function? No, definitely not a function, but it's still a relation, so we can still describe the domain and range. Here we go. Domain, I'll use green. So left to right. Can x be negative 5 right here? No. Negative 4? No. Negative 3? No. Negative 2? No. But definitely negative 1. Look at x can be negative 1. X can be 0. Look, because you have points there and there. If x is 0, you have points here and here. If x is 1, you have points here and here. So it seems that x can be any number in between negative 1 and positive 5. So here's our domain. X, you always put the smaller number on the left. Be careful here because you're going to do a pair share right now. Get it right. X is going to be greater than or equal to the smaller number. In this case is negative 1. That's always on the left. But it can be less than or equal to positive 5. The bigger number's on the right. So x can be anything greater than negative 1, less than 5, and equal to those numbers. All right, now the range. Let me use blue for range right here. I'm looking at the y-axis only. Is there values for y being negative 5? No. Negative 4? No. Negative 3? Yes. Look at the y value is negative 3 right there. Negative 2, yeah. Look at, you have y values negative 2 here. Y values of negative 1 here. Y values of 0 right here. Y values of positive 1 right here. Y values of positive 2 and a y value of positive 3, and it stops there. So it seems like y can be whatever. Okay, I'm going to highlight whatever's in blue. From here to right there. So y can be any numbers where I just colored in blue. So let's write it down. Here we go. Y, the smaller number is going to be negative 3. So y can be bigger than or equal to negative 3, but less than or equal to positive 3. This is the maximum up here. That's the positive 3. Here's the minimum. That's the negative 3. Last but not least. Actually, there's two more. This one, and we're going to draw one more. Sorry about that. Second to last. All right, domain. Green, left to right. So if x is negative 10, y will be something down here, because look at the arrows. If x is negative 9, y will be something down here. So x can be from negative 10, negative 9, all the way from negative infinity, now coming this way. X is defined here, x is defined, x is even defined over here, all the way up here. So domain is all real numbers for x. X can be any number on the number line. How about range? Let's try range. Put the range in blue. Okay, y a negative 5, yeah, right here. Y can be negative 5. How about negative 6? Yeah, right here. Negative 7, yeah, right here. So far negative infinity for y, because there's an arrow. And look at positive infinity for y. Y can be any of these values. They're all right here. So again, all real numbers for the domain, or for the range, rather. Okay. Now, flip the page. 7, 8, and 9. 7, 8, 9, and 10. That's going to be for you and your partner, but right now, at the bottom, after 10, go ahead and copy this graph down. Make a simple x and y axis. We're going to do this one. This is the last example. So this is example 11. Oops. Copy this example down. So just make a simple x and y axis and then copy this graph. So we're skipping 7, 8, 9, 10, and we're going to add number 11. This is our last example together for notes. So put it somewhere at the bottom. This one you're drawing. All right, so this one's kind of a tricky one. Notice this open circle here. This open circle means the function is not defined there. It's undefined there. So the closed circle, obviously, that means the function, let's see, that the point there would be, let's see, x would be 3. What would be your y value there for this one? 1. But over here, the point here would be, let's see, negative 5 and then positive 5, but it's open. That means it's not closed. That means the function doesn't exist there. Okay, that's what the open circle means. The function does not exist. So x cannot be negative 5. So here's negative 5 right here. X cannot be negative 5 because there's no dot there. It's open. But what this function is telling you is, look, x can be any number infinitely close to 5, or to negative 5, getting closer and closer and closer infinitely, but never actually touching 5. Negative 5, I should say, not positive 5. Positive 5 is over here. So imagine x approaching negative 5, but never actually touching it. So a point right here would be on the function, would be like negative 4.999. Y would be 1, 2, 3, 4, positive 4.999. But it'll never actually be 5. It approaches it infinitely closer and closer, but never becomes 5. How about if x is negative 4.99999? Imagine getting closer and closer. So if x is negative 4.99999, y will be, let's see, 1, 2, 3, 4, almost 5. Y will also be positive 4.99999. That's what this is telling you. The function gets closer and closer to 5 without actually ever becoming 5. That's what the open circle means. So What's the domain and range? Here we go. The domain I'll put in green. I'll put D for domain. And then R for range. So let's see. So let me use a green. X can never be -5. I just established that. Here's -5. It can only be numbers bigger than -5. Look at this way. But never becoming -5 because it's open circle. So X can be any number bigger than -5, and it can actually become 3. So look at our domain. -5. X can only be bigger than -5, not equal. Look at not equal because open circle. So X can be bigger than -5, so it can be -4.99999, but it can never be -5. So X can be greater than -5, or I should say n less than or equal to +3. There's your domain. Notice how it never becomes -5. How about the range? The range can be, notice where I'm shading. Y can be any number from +1, but never actually becoming 5. So it can be 4.999, but it never becomes 5. That's what the open circle is. So the range then is, you always put the smaller number, +1. Y can be greater than or equal to +1, but less than 5. Notice how I don't put the equal sign. It's only less than 5. Careful there. Okay, 7, 8, 9, and 10, just 4 problems. You're going to do it with your partner. Okay? So 7, 8, 9, and 10, you're going to do it with your partner. After you, if you want to come and see the eclipse, because we have 5 more minutes until it's maximum.